Okay guys, so let's solve this question here. So what we have is 11.1. A and B are two events in a sample space. The probability of not A is equals to 0.45. The probability of B is equals to 0.35, right? So in 11.1.1, determine the probability of A or B if A and B are mutually exclusive. So mutually exclusive events have an intersection. So this is an intersection. A and B is equals to 0, right? So to find this here, we need to write down the formula. Formula of P of A or B is equals to probability of A plus the probability of B minus the probability of A and B, of which we just stated that the probability of A and B is equal to 0. Why? Because A and B are mutually exclusive. So you're just going to write down P of A or B is equals to the probability of A plus the probability of B. So now this is the formula. But now we don't know the probability of A. We are only given the probability of B, which is equal to 0.35. And the probability of not A, which is equal to 0.45. So to find the probability of A, we're going to see the probability of A is equals to 1 minus the probability of not A. So that's how we find it. Then you're going to say 1 minus the probability of not A, it's 0.45, so it's 0.45, right? And then your calculator should give you 0.55. So meaning that the probability of A is equal to 0.55. Then you come to your formula. So it's going to be probability of A or B is equal to, what's the probability of A? It's the one that we just found, 0.55, plus the probability of B, which is what is given as 0.35. So your final answer here should be 0.9. So that's how we solve this question here. So now let's move to 11.2, right? So 11.2, we are asked to determine the probability of A and B if probability of A and B are independent events. So if they are independent events, this formula applies. The probability of A and the probability of B, it's equals to the probability of A multiplied by the probability of B. So this works only if events are independent, right? Only for independent events. Now, what's the probability of A? We just calculated it in the previous question. It was 0.55. So 0.55 multiplied by, what's the probability of B? It's 0.35. 0.35. Then you multiply that into your calculator. Should get 0.1925. So that's the answer for this question. So please note that these type of questions are actually grade 11 questions. So they'll always appear in your grade 12 paper. So you just need to be able to understand them. Let's go to 11.2. 11.2 is it's an interesting question actually. It's also a grade 11 question, by the way, but it always appears in your grade 12. So what you're given here is a classroom has 14 black chairs and 18 red chairs. During the day, 2 chairs are randomly removed, right, for a meeting in another classroom. Determine the probability that, both taken chairs are arrayed. So say for example, we have black chairs, 1, 2, I'm not going to write all 14, right? We have these black chairs, and then we have these red chairs, right? I'm not going to write 18. So what they're saying here is, what's the probability that both taken chairs were arrayed? So remember that they're taking 2 chairs randomly to another class. So now the question says that what's the probability that they're going to take 2 red chairs? So instead of taking black chairs, they're going to take these 2 red chairs. What's the probability of that? So how we can find that, let's try and draw a tree diagram, which would help us. It makes things a bit easier. You can calculate this with your head, but let's just use a tree diagram because I can calculate this with my head. Like for example, the probability of red chairs is equal to the total number of red chairs. What is it? It's 18 chairs, right, that are red. And then what is the total number of chairs in total? So now you're including both 14 and 18, you're going to get 32 chairs. So the first thing here is, say the first phase is you're going to take 1 out of the 18 red chairs because we want 2. Remember, we want 2 red chairs. So you're going to take 1. And then you come again, you take another 1 so that it makes 2, right? So when you come again and take another red chair, how many red chairs are now left? You took 1, so how many are left? 17, right? So 17 chairs are left, and then the total number of chairs is also affected. There were 32 chairs, but you took 1 chair. Now you're left with 31 chairs. So it's going to be 31 chairs, right? So these are the probabilities. So what you're going to do is, you're going to say, therefore, the probability of taking both red, right, is equals to the probability of taking a red the first time multiplied by the probability of taking a red the second time. So meaning this is the first time, which is 18 over 32, multiplied by the second time, which is 17 over 31. Then your answer should be 0.3085. So this is the final answer. But now I was mentioning a tree diagram. You can do this with a tree diagram. It makes your life a bit easier. So you can have your tree diagram like this, where you have your red, you have your blue, and then another leaf here where you have your red and your blue. Another branch, why did I say leaf? Another branch here, red and blue, right? So the first phase, you know very well that you have how many red chairs? 18 red chairs out of 32. And then once you get here, they're no longer 18 but 17 chairs that are red and 31 in total, right? And then this value here, how you find it, you're just gonna minus. You're gonna say 1 minus the 17 over 31. You're going to get the value for here, which should be 18 over 31, right? No, I'm lying. It actually is supposed to be 14 over 31. Cool. And then now the black chairs are 14 over 32, right? And then here we're gonna have 13 over 31, and then here on top it's going to be 18 over 31, right? Fine. So that's how we draw the tree diagram. So remember, the question says that the probability that you get both red chairs. So this is red, this is also red, right? You're going for red. So meaning you're going to multiply this probability with this probability, which is what we just did. Multiply this probability with this probability, and then we've got our answer here. So that's how you can do it also another way. Anyways, let's move on to another question. Let me just not remove the tree diagram. It might help us on the follow-up question. So the second question says that we should determine the probability of taking a black and a red chair, right? So you're taking a black and a red chair now. So what's the probability? Probability of taking a black and a red, right? Which is the probability of black multiplied by the probability of red. It's just as simple as that. What's the probability of black? It's 14 chairs out of how many chairs? 32. Probability of red, it's 18 chairs out of how many? 31. Why 31 now? Because you've already taken 1 chair out of the total for the black. 31 will remain. That's just what it means, right? But if you're getting confused, you can go to a tree diagram. We are taking a black and a red. So this is the black, right? And this is the probability of a black. And then this is a red, and this is the probability of a red. So now you understand why we wrote these answers, right? These answers here. Right. So now I'm just going to punch that into your calculator. You should get something like 0.25. Right. So that is going to be a final answer. Now let's go to this question here. Okay, this one is a bit interesting also. What do we have here? We are told 5 boys and 4 girls go to the movies. They are all seated next to each other in the same row. So these people, let me just indicate this because it's just small numbers. 5 boys, this is a boy, this is a boy, this is a boy, this is a boy, this is a boy. They're seated. So they didn't say 5 boys seated next to each other, 4 girls seated next. No. I'm just literally just writing this. I can write it randomly. Boys, girl, boy, girl. Doesn't really matter. So these are girls, 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 girls. Right? 4 girls, 5 boys. Right? Seated next to each other. So they can be seated randomly. Can be a boy, can be a girl, can be a boy. It just doesn't matter. So now the question says that 11.3.1, how many ways can the entire group, so the entire group meaning we are grouping all boys and girls into one, be seated in the row, right? How many can all these people be seated in a row? Not individually. You see, if they said how many ways can boys be seated and girls be seated, at least you're being specific by saying boys and girls. But here you just mentioned the entire group, so you don't care much about the gender on whether it's a boy or a girl. Just saying how many ways can the entire group be seated. So what is the number of this entire group? I mean, 5 plus 4 is equals to 9. So this is the group of learners, right, which is 9. So you're just going to say 9 factorial. Use factorials. So if you haven't done probability yet, this is a factorial. The factorial, you can look at it in your calculator. Just under the on button, you should be able to find it. I'm not sure if it's just close to the log button. Just depends on the calculator you have. But this is a factorial function. So which means you're just going to multiply, you're going to punch it in your calculator and say 9 factorial. What is 9 factorial? And you should get 362,880. So this is the answer for this question here. Hope you understood. If you didn't, please let me know in the comment section. I will answer you. So now let's go to the second part of the question, which is 11.3.2. 1 boy and a girl are a couple. Ooh. So this is your boyfriend and yourself, or your girlfriend and yourself, if I may put it that way. So you guys are a couple and you want to be seated next to each other. That's what the question says. Couple goals. You want to be seated next to each other. So remember, you have friends. So all of you are 9 in total. Remember, all of you are 9 in total. So it's still the same statement here. It's still this. So you're 9, but you just want to be seated next to your partner, That's what the statement says here. So in how many ways can the entire group be seated? So your aim is to sit next to your partner. You don't care about anything else. So let me show you this. So I'm just going to write down the total number of you guys as a group. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Remember, it's boys, girls, boys, girls. It's just boys, girls. But you, as a boy, I'm just going to write B for boy. You want to be seated next to a girl, right? Let me just indicate with a different color. So you want to be seated next to a girl, your partner, your girlfriend. So these are you guys. You are seated. So now I'm just going to indicate the number of ways that you guys are seated. Just this way. So as you are seated here, how many are you? You are 2, right? We're a couple. So it's just going to say 2 factorial. That's what it means. 2 factorial, meaning it's either the boy sits here and the girl sits here, or the girl sits here and the boy sits here. That's just what it means. You can see it vice versa. We don't care on, like, you see, that's why we indicate factorial, because you can be seated on either chair. That's what it means. So now, and then your friends, we don't really care whether they sit as a couple or not. So it's just boy. I'm just going to indicate all the boys. Remember, boys are 5, if I'm mistaken. Yes. So I'm just going to add 4 more boys. Boy, boy, boys, and boy. Right, and then girls. Girls, girls, girls. Remember, girls are 4. So we don't really care how they're seated, because they can be seated randomly. How many are they in total? How many are these people in total? There's 1 here, 2, 3, 4, 5, 6, 7. So there are 7 in total, meaning it's 7 factorial. They can be seated in different ways in these seats. So what's most important is you and your girlfriend being seated together. But you won't just be seated together on this side, right? You can also be seated together on this other side, right? Remember, they said a boy and a girl wants to sit next to each other at the end of the row of friends. That's why I underlined this statement, at the end of the row of friends. So it's either you're seated on this side or you're seated on that other side. So there are 2 ways that you guys can be seated with your girlfriend. Hence, you need to indicate that also. So you're going to be like, okay, fine, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And then you guys will be seated here again, which is 2 factorial. So it's a boy and a girl. And then your friends will be seated in 7 factorial, right? We don't care how they are seated, right? So we really don't care. So yeah. So that's how you do it. So it's either you guys are seated like this or you're seated like this. So that's how it works. So now let's put this into numbers. So you're gonna say this 2 factorial multiplied by the 7 factorial. So 2 factorial multiplied by 7 factorial plus this 7 factorial multiplied by this 2 factorial. 7 factorial multiplied by 2 factorial should give you an answer for this question. And please do punch in your calculator. I'm getting 20160. Right, so this is the answer for this question here. Now let's go to the last question. I think it's the last question. So in this last question, what does it say? If all friends are seated randomly, right? Calculate the probability that all girls are seated next to each other. So remember, there are 5 boys and 4 girls, right? So they are saying, what is the probability of girls being seated next to each other? The probability of girls being seated next to each other. So meaning, you're going to say, okay, fine, because there are 4 girls, so it's going to be 4 factorial. That's the first step, right? And then you're going to multiply that with what? So because you want these girls to be seated next to each other, you're going to treat them as one. So this is just one group, right? So this one group of girls plus the 5 boys. And then you close this to say factorial. It's equals to 6 factorial. So you're going to write that 6 factorial here. I hope what I did just makes sense to you. You are grouping the girls into one. They are going to be seated next to each other, right? So you're grouping them into one. And once you group them into one, you add with the number of boys that are going to be seated. So it's going to be 6 ways, 6 factorials, right? And then you divide by the total number. How many are you people? See, I'm not saying how many are you girls or how many are you boys. How many are you people seated there? There's a total of 9 people that are seated, right? So that's how we write down the probability for this. And if you punch this in your calculator, you should get 1/21 as your final answer. So I hope you guys did understand probability, but if you have any questions regarding this particular topic, let me know in the comment section if you have them, or you just want me to help you with whatever topic you have in mind. Let me know also in the comment section. You're more than welcome to ask any question whatsoever. Alright, thank you so much for watching. If you haven't subscribed, please do subscribe and like this video if it was really interesting. If you did gain anything, because that's the whole purpose, is for you to gain something here. Thank you so much for watching. Take care. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.